Good evening, this is Citizen Slave with another episode of Space Engineers Let's Play Survival in version 1.190.101. So you can see I've got the MegaMiner parked on the side of our Space Industrial Complex here. It is no longer attached to that connector up there on the top. That was so I could clamp the landing gear on without interfering and spin the drills without it interfering. And crashing into things and breaking a bunch of stuff. In between episodes, I did a little bit of work on the scripting for the MegaMiner, and I made some decent progress. We're going to do a little bit more on camera here as a bit of a tutorial and review what we actually did do. So I've got three commands set up here on the hotbar. One starts the drills, so that turns the drills on, starts the rotor spinning, and begins slowly extending the drill piston. Meteor storm, yay! Hopefully that doesn't hit anything important. I think, yeah, oh, no, the sun's not behind the asteroid, so we could potentially get hit, but we haven't yet, so knock on wood. Slowly extending the piston that is attached to the drills, the drill piston. Um, so then that'll, spin and extend and drill and collect a bunch of stuff. Three, pauses. So the drills are going to keep spinning just because spinning up and slowing down the rotor um, is a little bit finicky. So I figured I would just leave the drill spinning and let them continue anyway. And this is going to stop collecting ore, so we won't get anything else as long as we're paused, because the pistons won't extend any further, so we won't get bound up or anything like that. So we won't have any issues. It's okay if it spins. That's not going to cause any problems. But the drills themselves will not spin. They're not active, so they won't be collecting any more ore. And the idea is that we'll do this when we're actually full of cargo. We want to wait for some of it to process through the refiner or the O2H2 generator in the case of ice. And then we can unpause. We can also just hit start again to continue when paused. Also, when we're paused, we can stop. Now, stop turns the drills back on because I want to drill on the way up just to make sure we don't get caught on anything. And it slows the rotor down and stops it back in the vertical position. And I did something a little bit funky to make that happen, because trying to do the upper and lower bound, the upper and lower limit, I had some issues. One, getting it set to unlimited so it would actually spin the entire way around, and two, actually getting it to stop. When I set it back to 0 through code, sometimes it would just go completely crazy and start spinning super fast and then break, and that's not good. So rather than mess with any of that with the upper and lower limit, I just set the velocity so that it will continue until it gets to 270 degrees, and then it will proportionally slow down as it gets closer and closer to 360 or back to 0, however you want to look at it. Um, and then finally stop and lock up when it gets to that position. I'll show you the code for that in just a minute. So start, stop, we'll bring it back. And it'll complete a rotation to do that, and then it'll actually turn the drills off once it's fully reset, and then the pause command. Now, let's look at the code and see how we did this nonsense. So there's definitely some more that can be added to this kind of as enhancements. I'm echoing out the drill state to the console here. We can make that go to an LCD panel in the cockpit if we choose to do that, which I'll probably do at some point, maybe today on the episode, maybe not, we'll see. Anyway, these are the various variables for holding the items that we need to work with. The drills are going into a list. The drill rotor is being stored just by itself. The drill piston is being stored just by itself. Then we have a string to hold the drill state, because we want to keep that preserved between calls, between ticks, runs through main, so we can save this outside here as part of the general program class. And then what is actually a constant, but I couldn't declare it as a constant again because it's an array, I guess. I'm not sure. I'm going to have to learn some C# about declaring constants and why I've been having issues declaring constants, but it's capital letters, so you know it's intended to be a constant anyway. That contains the possible commands that you can send in, so we can check any commands that are being run against this list and make sure that we're not trying to do something funky. So then we instantiate the program, set the runtime frequency to update 100. We could do a lot of this based on just when you actually run the command, but when we're stopping in particular, we need to do updates and check and see where the drills are to see if they've retracted all the way or see if they're spun into the right position on the rotor. So we're going to go ahead and update every 100 ticks. Grab the drill rotor, grab it by name, grab the drill piston, grab it by name, and then grab all the drills. Only return them if they're on the same construct. So we're not going to get the colonizer's drills, for example, if we're connected by the connector here. We're not going to get the ice station's drills if we're connected over there. So we don't have to worry about that happening. Then we're doing something here that I've actually never done before, and was really, really easy. Um, I imagine there's a better way to do this if you're going to have more stuff that you're going to save, but this method here that we didn't use on the colonizer, at least we haven't used yet, saves information to this storage variable whenever you save the game or whenever the game is saved, or I'm not sure exactly how frequently it runs. It seems to run pretty frequently. It seems to run more frequently than when you actually just save the game, because when I've restarted the programming block, just between saves, it's always been updated. But anyway, we're checking to see if there's anything saved there. If there is something saved there, then storage will not be an empty string, and we will save the drill state from storage. And here we're saving the drill state to storage. So it's just one simple string going in, then one simple string going out. And if it's not set, then we're going to update the drill state, and you'll see what that method does in a minute with the command stop, which is one of these here. So we can basically command the drill directly by calling update drill state and then passing in the appropriate command. Usually that's happening down here in the main method through the argument received from the command here. Anyway, so save, like I said, we're just saving the drill state to storage, real plain and simple. Then here in our main method, this is the same kind of code that we have over in the colonizer to make sure that we're only doing, update 100 tasks on update 100, and we're not going to do them again, for example, when we send in a command. I don't know that this is really important in this condition either, because what we're doing is really quick, and if we do an extra trick on the drill, it's not going to be the end of the world. But anyway, this is where we check the drill, and right now this is only doing anything when we're in stopping mode, when we've sent the stop command, but we haven't completely stopped yet because we're still retracting the piston and spinning the rotor into position. That's when we actually get to stopped, is when both of those things have happened. So check drill is only really doing anything at this point during the stopping state, when drill state equals stopping, after you send the command stopped. But that'll change. We're going to be augmenting this a little bit so that when the cargo is full, it will automatically pause, and when it fully extends the piston, it will automatically stop and retract everything and say, okay, we're done now. So that's some things that we're going to add, and we'll probably add those today on camera as long as we have enough time to get through all that. So then here we're saying if update source does not equal update type none, because it equals none after you've turned everything off. So if it's running for no reason, basically, which doesn't actually happen, I don't think. I'm pretty sure that's kind of the intention there, is that you're always going to have some kind of update type. So if you turn off the update 100, then that leaves, you've manually run it, and you're going to have an argument. And if you don't have an argument, then it's going to be an invalid command. But we'll echo received argument, then print out the argument. So if I actually do run a command through the console or through the hotbar even, it'll echo it out. Can't see it when we run it through the hotbar, because by the time we actually get into the terminal to see what the command was, it will have gone on to the next tick and it'll just be displaying the drill state again. But in any case, it will echo that out, and then if it's the drill commands array that we have set up here does not contain the argument, it'll say it's an invalid command. Else, meaning it is a valid command, it'll be updating the drill state, and it'll call update drill state with the argument, just like it did here where it specifically updated it to stop. Then we come into update drill state, and this is where the real meat of it starts. There's also check drill, which is going to be kind of important, but we'll go into that in a moment. So this is where we're specifically updating the drill state, and a lot of the stuff that we're doing when we update the drill state we can do directly here. It would probably be nice to pull this out into its own methods rather than kind of bunching it all in here, but I don't think that it's really necessary to do that, so I just went ahead and bunched it all in here. So we're on the outermost if blocks here, we're checking the actual command that's being sent. So if command equals stop, else if command equals start, else if command equals pause. And there's no else here, because the only way that you can get in here is if the command that you send is in this drill commands array, and there's only stop, start, and pause. So there's no need for an else condition at the bottom here. Then in the inner, in the code blocks here, if the command is stop, then it doesn't matter what state we're in unless we're stopped or stopping. So if we're already stopped, there's nothing to do. If we're stopping, there's nothing else to do. So set the drill state to stopping, and then if you run stop twice, it won't do anything if you run them in sequence like that. Drill piston velocity to minus zero point 0.1, so this is going to pull it out quicker than it pushes it in, because you can see the velocity here is set to 0.02 for start, and we'll get into this in just a second. Make sure the drill piston is turned on, and then turn the drills on. So pretty straightforward. Uh, Oh, I'm sorry. Yeah, this is turning the drills on because, like I said, I wanted the drills to actually be running when we pulled it out. So if we're paused, for example, the drills will be stopped. If we are stopping from paused, then we want to turn the drills back on so that they're running while they pull the drills out, just to make sure we don't get bound up on anything. Okay, next, if the command equals start, if the drill state is not drilling, then or if the drill state rather is drilling, there's nothing to do, so return. If it's not drilling, and this is something that we're probably going to add in here at some point, we want to check the clamps and make sure that at least one of them is engaged and that the thrusters are turned off. Um, if that's not the case, then we'll want to turn the thrusters off. But I think we're just going to bail if it's not clamped because we don't necessarily know what we're clamping to and if it's a good idea or not. We may say if it's ready to lock, then go ahead and lock. But if it's not ready to lock, then we're not going to try to maneuver or do anything crazy like that to find something to lock onto. So this is going to be mostly a safety check, and if it doesn't pass the safety check, then we're going to stop. Anyway, once that's been verified, which again we're not doing now, so once we're sure we're not already drilling, we'll set the state to drilling so we can't run it again. Toggle blocks for the drills to on. This toggle blocks method is one that I wrote, and I'll show you that in just a second. It just goes through everything that's in this list and sets the enabled state to whatever you pass in here. So toggle blocks drills true, turns all the drills on. Toggle blocks drills false would turn them all off, and you'll see that in a second. So turn all the drills on, enable the piston so that it's turned on, set the velocity to 0.02, meaning that it's extending out very slowly, turn on the drill rotor, disengage the lock, and set the rotation speed to 6 rotations per second, or per minute rather, 6 RPM. So that starts the rotor spinning. And that's all we need to do. So there's nothing else that goes into drilling. So that doesn't need to be followed up on or anything in the following ticks. Stopping does, and we'll see what that does in a second. Now for pause, it's a little bit more complicated because pause both pauses and unpauses. So if we're stopped or stopping, then we don't want to do anything because we don't want to allow you to pause when you're already pulling the drill out. We just want to go ahead and stop. Next, if we're paused already, then we need to switch back into drilling, turn the drills on, and re-enable the piston. If we're not paused, then we're drilling, and we might want to verify that, but really I'm pretty confident that we don't have to worry about it. We can just count on it. Set the drill state to paused, turn the drills off, disable the piston. So this will just freeze it in place. The rotor will continue to spin. We saw that a moment ago when I was demonstrating it. Now check drill. This is the one that runs every 100 ticks, and this is really just checking the drill state for stopping. Everything else here does nothing. So if we're paused or we're stopped, go ahead and do nothing. If we're drilling, we're going to do some stuff, but we're not doing it yet, so also do nothing. What really we're worried about here is if we're stopping. So if we've sent the stop command, but we haven't completed it yet, because you see up here when we said the stop command, we set the drill state to stopping. So then when we check drills on the next run, we're going to be here and it's going to call stop drills. Now stop drills, I said we're doing some shenanigans here with the rotor to get it to do what it needs to do. So first we set this boolean for stopped to true. We're going to assume that we're done, and then we're going to unset this as we go through here and find that conditions aren't actually met. So if the drill rotor's angle is less than 0.2 degrees or the angle is less than 359.8 degrees. So I'm giving a 2 degree or a 0.2 degree kind of cushion on either side, just because we are only running every 100 ticks and we want to make sure that we catch it somewhere in that vicinity, and that is close enough that we don't have to worry about things getting fried. Now the angle is in radians, so we have to use the math helper to radians function to convert that. I had initially written my own. I didn't realize that there was a math helper function already there. So definitely use stuff that's built in if you have the option to, because usually it's written better than something you're going to write, just off the cuff. Anyway, if the drill rotor is between 359.8 and 0.2 degrees, meaning it's basically completely vertical, maybe just a little bit off, then set the target velocity for the rotor to 0, turn on the rotor lock, turn off the rotor. And then we're going to move on. We don't unset stopped because that's the correct condition for stopped. If it's not the case, if the rotor is not at that, precise angle, then stopped is false. So we're not ready to stop yet. So this is being false, set to false. And we're going to reset the drill rotor's target velocity because we don't want it to fully spin at 6 RPMs, especially if it's getting close to the point where it's going to be lined up, because otherwise we'll probably miss it before we run again on the next tick. And maybe even if we set to update one so that it actually ran every tick, we'd still miss it because, I mean, if it's spinning fast enough, then a tick is not going to be quick enough to catch it. So we're setting this to slow down. But the way that we're doing that is we're saying if the angle is more than 270 degrees, we're going to slow down. If it's not the case, then just leave it at 6. So anywhere from, just past the top all the way around to, you know, 90 degrees short of the top, or 270 degrees, we're going to continue on at 6 RPMs. If we are between 270 and 360 here, because you know that we're not at 360, because if we were, we'd have done this and stopped it. So if we're between there, if we're on that last 90-degree swing, then we're going to take the angle that the rotor is at as a proportion of a full circle, and I should convert this to degrees just so it's easier to deal with, but there's really no need. 2 times pi. 2 pi is 360 degrees in radians, for those of you who forgot geometry. Um, I did. I had to look it up, so I mean, no shame in that. Anyway, so we're getting the proportion of our way through the arc that we are. So 270 degrees is going to be uh, three halves pi, I think. Anyway, so 3 halves pi divided by 2 pi is going to end up giving you 3/4 basically. But then 1 minus that is going to give you 1/4, and then we're going to multiply that by 24. So at 270 degrees, it's still going to be 6 RPMs. But then as this angle goes up, 1 minus this proportion is going to go down. So this speed is going to get lower and lower. And since I knew that we were starting at 1/4, I set this to 24 so that it would specifically come out the same as the 6 RPMs that we're using usually. And then we're going to slow down from there. So by the time we're getting up to, 350, 355 degrees, it's going to be going much slower so that it doesn't just sail past and miss it. Now, if you give the stop command when you're near the top anyway, it will still miss it just because it's going to slow down too quickly for the 100 ticks to catch it, but it'll only go around another 1 rotation. If it does actually get to it before it gets to the 270 here and it has that full 90-degree arc to slow down, it will catch it every time that I've seen. But yeah, like I said, there's a little bit of shenaniganry there as far as how I made that work because I was having issues with the upper and lower limits because every time I tried to use it, it wouldn't actually do unlimited and continuously spin. And when I tried to set it to 0 to lock it into place, sometimes it would get all clangy and end up spinning the rotors clear off the rotor part clear off the rotor, break the rotor itself actually, and we'd end up with just the piston head, um, floating free. And that's obviously not what we want to do. So I figured just changing the speed of the rotor and eventually stopping it when it was in the correct position was the best way to go there. So anyway, that's how we deal with the rotor. Like I said, we set this stop to false as soon as we realize that we're not in the right position, so we don't flip the state here. But if that is the case, then we'll lock the rotor, we won't reset it, but then we might still do that if the piston is not reset. So if the piston's current position equals 0, in other words, if we're fully retracted, set the piston velocity to 0 and turn it off because it takes a minuscule amount of power and might as well not use it, so I turn it off. So that will also not change the stopped condition. So if we have the rotor set and the piston set, stopped is still true by the time we get through here. If the piston's not set, then all we got to do is set stop to false. So if it's set already, then whatever, but if it's not set, then it will be. So then we check if we're stopped. And again, if both of these conditions have been met successfully, then it's still true from the beginning. If either one of them has failed, then it's going to be false and we're going to skip this. So if it's true, we set the drill state now to stopped. So we're back to the beginning position here, and when we send the start command, it'll do something. And we turn the drills off because the drills were running the entire time we were coming back here, remember? And then this is just the toggle blocks function here that I was mentioning earlier. It's a template function, so you can pass in a list of any functional blocks. And then when you say grab a functional block out of the list, turn it on or turn it off. Toggle it to whatever state you pass into the method here. So that's it. That's all that we've got here in this code. It's like I said, it's pretty straightforward. Just there's a little bit of shenaniganry there with the rotor. but that turned out to be the best way to do it. So now what we want to do is we want to augment this a little bit so that it's a little bit more intelligent in its functioning. We don't have to sit there and watch the cargo, for example, and we don't have to sit there and watch to see when it's fully extended to send it back. Now that's the easy one because we just have to check the piston position. So we just say if drill piston dot current position, which you'll remember we used down here to check the position if it's at 0. Here we're going to check and see if the current position is at the drill piston dot, oh, what's the property called? Max position, if I can spell. Update drill state, that's what it's called. Update drill state stop. So we're going to act just like you hit the stop button. It's going to be the same thing. Yeah, max position is not it. All right. 1 second, I'm going to find it. Because there's a specific attribute that pulls the current max position. Now, usually that's going to be fully extended. I don't foresee any reason why we're going to want to change that to be less than the 10 meters that we could possibly get it to. But I do want to make sure that we're using the actual maximum position. Because, I mean, if we're waiting for it to get to 10 meters, but it's only ever going to go to 5 meters, it's going to be sitting there forever not doing anything, and that's pointless. So let me just get my web browser to cooperate here. And again, I'm going to the scripting API that is on GitHub with a wiki and walks you through all of the, well, it doesn't really walk you through much of it, but it has the documentation that lists all of the various API properties and methods and everything on all of the various interfaces that you have access to through the scripting interface. I think it's exhaustive. I don't know that there's anything on it that you can do that isn't listed on the page, on the site. It's always seemed pretty complete to me. And I'm really just trying to fill time here now while I wait for my browser to load. I really need a new machine. Space Engineers kills my performance. In your own time. I will put this source code on my GitHub as well. So if you want to take a closer look at it, or if I've talked too fast to let you catch what was going on, I will have the source code posted so you can look over it yourselves. By all means, ask me any questions that you may have in the comments. I'm more than happy to try to help if there's something that you don't understand. Again, just trying to fill the time while I'm waiting for things to happen. Oh, really, browser, you're killing me here. My extended piston base is the name of the interface for the piston. There is also a my piston base. I'm not really sure what the difference is. I haven't tried using it. That's not actually linked directly from the main site, so I haven't really messed with that one too much. So it's max limit. Highest position is always going to be 10. Highest position is the maximum value for max limit. Max limit. And then lowest position is always going to be 0. It's the lowest position for min limit. Anyway, the value that we are looking for is not max position, it is max limit. There we go. So now when this is fully extended, it will automatically retract. And we will demonstrate that while we are working on the next bit. You can kind of see that happening in the background, and you'll see when it does get fully extended, it'll automatically pull back. So now the next thing we want to do, and this is a little bit more complicated. By the way, we're doing all this in the check drill function, that the one that gets run every 100 ticks when we come in through the update 100 update type call check drill. And we check to see if it was stopping, we stop the drills. If we pause or stopped, then we do nothing. But if we're drilling, we want to make sure that the piston is not at its max limit. If it is, stop. Now this one's going to be a little bit more complicated because we actually have to get access to all of the cargo. Then we have to figure out what's full versus what's still available. And if we've crossed a certain threshold, we're going to want to go ahead and pause so that we can allow some of that stuff to process. Yeah, I mean, we could have it set to a flag or do some dynamic checking to see if the basic refinery is turned on, and if there's something that is in the cargo that we can run through it. And the same with ice and the O2H2 generator, or turn those machines on manually, or manually, automatically, whatever. Check if they're on already, and if they're not, turn them on. We could do all that, but I think I'm just gonna pause and assume that they're on. And if you're sitting there watching it and it's not doing anything, you can either turn them on or you can go ahead and stop the drill manually, at least for now. So what this is going to entail, first of all, and I'm going to break this out into another method because it's going to get complicated. I'm going to say if is cargo full, and I'm going to do a percent. I'm going to pass in a value here, basically indicating a percentage of fullness, because we are going to keep the drills running when they pull out, and we don't necessarily want to get completely full. Like, we want to have a little bit of cushion there, especially and the main reason, honestly, is because these drills won't necessarily fill up evenly. Like the center drill there is going to pull some of the ore out that the next layer of drills could get access to. So the one in the middle is most likely going to end up full before any of the other ones, because all the other ones are kind of getting some of their ore stolen from them by the earlier layer of drills. So because they're not going to fill up evenly, I do want to put a little bit of cushion in here because I do want to count the drills as part of our cargo space. So I'm going to do 0.9%. And that's what we're going to call that. It's going to be a percentage or a ratio of fullness. So if is cargo full to 90% or to 0.9, then we're going to update drill state to pause. And remember again that this is basically the same thing as sending the command in through the hotbar. So now we have to actually define this is cargo full method. And that's going to return a Boolean because it's inside of an if statement, so it has to return true or false. It has to evaluate to true or false. Is cargo full float percent full. Return false. So until we get this running, it will always assume that it is not full. Next, we need a float max cargo equals 0. Float current cargo equals 0. Now, I'm not sure that we're actually going to need to use this list because I think we can do the same kind of trick that we did on the colonizer, where we're using the filter function for get blocks or get blocks of type to do the work of populating max cargo and current cargo for us. But I'm pretty sure you can't just pass null in there or it'll throw an error. So we will go ahead and create a list, even if we don't end up doing anything with it. A list of my terminal block containers is a new list of my terminal block. Now grid terminal system dot get blocks of type Now, I was always putting the brackets in here and actually specifying, but you don't really have to do that because it'll read it based on the type of list that you pass in. So if I just pass in containers, it'll know that it's looking for IMyTerminal blocks. I'm just going to do that. Block. And here's where the magic's going to happen. We are not only going to quote-unquote filter the blocks that end up in containers, but we are also going to actually do the work to populate the max cargo and the current cargo. So, first thing we want to do, if is block, no, if not block dot is same construct as me, capital M. If it's not the same construct as me, return false. So if it's not on the MegaMiner, we don't want it. If not block dot has inventory, if there's no inventory, then it can't contribute to the amount of cargo. Return false. Is there anything else? You can see that that's still extending. It's about there. I think there's 2 sections, so it's not got a whole lot further to go before it'll automatically stop, or at least before it should automatically stop. Okay, so same construct and has inventory. I think that's it. I'm not entirely sure that we want to count the... Oh, I know we don't want to count the hydrogen tank. If... Oh, wow, I gotta remember this one now. Block definition dot subtype ID dot index of tank does not equal -1, meaning it is able to find tank in the subtype ID. Because if it can't find it, then it'll equal -1. If it can find it, then that means it is a tank of some kind. Return false. Just to check on our progress here, echo block dot custom name. So it's still going to be returning false here. Yep, there you go. It's retracting. It got all the way out, so it's stopping now. Now it's only going to actually run this while it's in drilling mode. So it's not going to run this at this point because it's stopping. Unless I change it. Well, it's going to run stop drills here because it's stopping. It require too much messing with it to get it to happen any other way. So we will just wait until that fully retracts to test it, and then we'll turn drilling back on. Although what I am going to do, because I'm sure that this is working now, is I'm going to comment this out so that it stays drilling even when it's fully extended, just because we're working on it and we want to make sure that it works correctly, and I don't want to have to wait for it to retract if it gets all the way out. I don't want to have to be in this position again. So anyway, what we're doing here so far, check if it's the same grid, check if it has an inventory, make sure it's not a tank, because the hydrogen tank here does have an inventory. It's only for bottles so that you can refill the bottles, but that we don't want to count because there's no ore that's going to go into that, so we don't want to count that one. And then if we get through those 3 checks, then we're going to echo out the custom name and see what we're left with. And if there's anything else that we need to filter out, we'll be able to do that at that point. So I'm going to echo out the custom name, and then I'm actually going to echo out the subtype ID as well, just so that I know I already know how to filter it out when we find something that's not what we're looking for. Block definition dot subtype ID. Not all code paths return a value. Oh. There are some instances here where we're not returning anything. It doesn't really matter. This is determining what goes into this list, and we're not using the list, so whatever. Assignment not used, that's fine. I'm not worried about that. So now when I start the drills again, and then go back into our controller, now you can see it's displaying everything. So the connector we want, the H2 generator apparently doesn't have a subtype, and I'm not sure we want that, because that can only take ice, and if we don't know for a fact that we're drilling ice, unless I check it, we don't want to count that inventory, because that's not going to fill up necessarily. So I think I do want to take that out, and I'll have to check the type ID for that one, because apparently it doesn't have a subtype. Small cargo container we want. Basic refinery we might want to take out as well, because again, if we're drilling for platinum ore, for example, or if we're drilling for ice, we don't know, what we can do with that. The basic assembler we definitely want to take out because it can't hold ores at all. The large cargo container we do want. The cockpit we do want. The reactor we don't want. And the drills we all want. Okay, so there's definitely some things on here that we want to filter out still. So we want to take out the O2H2 generator, and we need the type ID for that, because this is an empty line. There's no subtype ID for that. We want to take out the basic refinery. That's a blast furnace, apparently. And a basic assembler we want to take out. So blast furnace, basic assembler, and large block, small generator. So if block definition dot subtype ID dot index of blast furnace does not equal -1, return false. If block definition dot subtype ID index of basic assembler does not equal -1, return false. What was the block definition subtype ID dot index of large grid small generator, I think is what it was. Alright, and then I need to also get the type ID here, because subtype didn't work for the gas generator. Alright, and that's just the warnings about the two variables that we're not using. That's fine. Okay, so we've got the connector still, that's fine. We want to pull out the oxygen generator. Small container we want, large container we want, industrial cockpit we want, large block, it's large block, not large grid. That's where I screwed that one up. So the industrial cockpit we still want. Large block, small generator is what we want to pull out. And we also need to check the type ID for oxygen generator. Large block, small generator. Large block, small generator. Then lastly, if block definition dot type ID dot to string, because apparently it is not a string, so that's a problem, dot index of oxygen generator does not equal -1, return false. So we should just have the blocks that we want left here. Connector, small cargo container, large cargo container, cockpit, and then a bunch of drills. Perfect. All right, so we can stop echoing those out now, because that's just going to be mess, and we don't need mess. Take that out. Now, instead, what we want to do is we want to say, all right, all these blocks only have one inventory, so we don't have to worry about inventory counts. We can just get inventory 0. But now we want to do my inventory block inventory equals block dot get inventory 0. We want to do that so we don't have to get it more than once. Block, no, max cargo plus equals block inventory dot max volume current cargo plus equals block inventory dot current volume. Then when we're done, I am going to echo I'm going to interpolate the string current cargo out of max cargo This is just formatting. It's not important if you don't want to do it. And oddly enough, this is actually stored in kiloliters, if I remember correctly. And then I'm going to go ahead and calculate the percentage. No, I'm not going to calculate the percentage here. I'm going to calculate it here. Float percent full. Nope, that's what we call the parameter. Yeah, I am going to call it percent full because that makes more sense here. And I'm going to call this max percent full. Equals current cargo divided by max cargo. And I'm just going to do that. I don't want to convert it here because max percent full is a ratio rather than a percentage technically. So I'm going to do the conversion work actually right here. Percent full times 100 dot to string n2. What did I do? Cannot reply to my fixed point. Okay, I need to cast these because these are my fixed point type rather than floats technically. There's a direct cast though, so it's not a difficult conversion. Just need to actually do it. Compilation successful. All right. Now you got to flip this back and forth because it does the scrolling weird. Okay, there's 0 in there. We knew that, but yeah, that looks correct. 657 point whatever kiloliters. Odd unit to choose, I think, but whatever. All right, and then the idea is, well, and that's the idea, but we're not actually doing it yet. Do I want to display that? Yeah, I'll go ahead and display that because I think that that'll be useful information to have at some point. So we're probably going to change a lot of these echoes so that they are writing out to an LCD panel in the industrial cockpit. We'll do that later though, because I am running over time as usual. So we're just going to go ahead and finish this one up real quick, and we'll have to test it at another point because I'm not lined up to start drilling right now. We'll just say if percent full is greater than or equal to max percent full, update drill state. Nope. Return true. Else return false, because we're updating the drill state up here. So if is cargo full at 0.9, update drill state to pause. So we're just going to return true down here, because this is just determining if it's full or not. And if we need to use that for some other purpose, we can without it automatically pausing the drills again, or unpausing them if it's paused. Well, yeah, actually. We don't really have to worry about that because if it's paused, it's not going to get there. But anyway, the point is that if we run this method again, it won't be messing with the drills. It'll just be returning true or false. So we want to return true here rather than actually doing the work. So if percent full is greater than or equal to max percent full, return true. And that's it. Like I said, we're going to have to test that at another time because I am running over and I am not oriented in such a way as to conveniently do that testing from where we are or positioned or set up or whatever. So thank you very much for watching. Subscribe to see a test of this. Likes, comments, and verbal abuse are welcome. In the next episode, we're probably actually going to, at least I'm thinking about going back over to the ice station and setting up some of the scripting over there. We have a ton of ice for now, so I'm not super worried about ice, but we are going to want more ice at some point. We've got the O2H2 generator here full, so but we're not connected anymore to the space industry, so let me check that inventory real quick just to show you. The generators on the colonizer are full, and then in the cargo storage for the industrial center we have 683,000 ice, so that's a decent amount. I mean, there's no harm in having more. A lot of our cargo space here is actually being taken up by iron and other sorts of ingots rather than, we don't have any ore except for the ice, which is technically an ore, but that's about half of our space, a little bit more. I wouldn't mind having more ice. We do have a fair amount of cargo storage space here still in the second large cargo container, and a couple of small containers here elsewhere. All of our O2H2 generators on the station itself are full as well. So that's not bad, but you know, a little bit extra couldn't hurt anybody. Anyway, all that's for next time. Thanks for watching. See you then.